Hello, I'm going to do problem 1 of this current problem set 23, because I noticed there was a bit of trouble that some students were having, so hopefully this will help you. So what we have here is a beam. There's a beam that's attached to a wall. Well, it's actually attached to the wall by a hinge. So there's a hinge here, a beam, and then a sign hangs from it. And then there's this cord, this tension cord is going to be attached right here on the beam itself. The beam is 6 meters long, and the sign is 4 meters long, and the edge of the sign hits the edge of the beam right here. I've got 4 forces acting on this thing, as you can see. You can see from the picture. There'd be a tension force acting this way. The force of gravity always acts on the center of mass of an object. So the center of mass on this beam, the force of gravity from this beam, is going to be pointing downward, and it's going to act at the center of mass of the beam, which is directly at the center of the beam itself. So, in other words, the force of gravity from the beam is going to act 3 meters away from the wall. Lastly, the force of gravity that acts on this sign is going to act on the center of mass of the sign. Now, the beam is our object. So, while the center of mass of the sign is right here, I'm going to project it onto the beam, which is right here. So the sign is tugging down on the beam at the center of mass of the sign, which is a distance of, if this is 4 meters, that means this distance has to be 2 meters. It's going to be 2 meters away from this edge of the sign. Or because the beam is 6 meters long, it's 4 meters from the wall where this force is acting. Last force I have is the hinge force. I described that in class of what that hinge force is. The hinge force would act this way. It would act this way, and it would have y components, FHY, and x components, FHX. In the problem that I gave you, that textbook uses the term reaction force. That's why you have Rx and Ry, which is the question for part C. But right now I'm just going to do part A. They ask for what is the tension force. So what is that tension force? I'm going to use this idea that torque net equals 0. This object, this whole system is in equilibrium. It is not moving, so the net torque has to equal 0. Now what is the net torque? What is the sum of those torques? Well, I get a torque from the tension force, and that would act positively because, this is my origin. I'm going to make this my origin right here. It's a clever place to make your origin because it's going to cancel out an unknown. It's going to cancel out this hinge force that I don't know what the answer is to that. So that's a good place to put your origin. So I got a torque from the tension force. If this is my origin and I applied a force like this on the bar would rotate counterclockwise, which makes that positive. Next, I have this gravitational force from the sign. So I'm going to have a torque from the sign. Here's my axis. If I applied a force this way on the bar would spin clockwise. So that tells me that it's going to be negative. So the torque from the sign is going to give me a negative torque. And then I also have a torque from that force, the force of gravity that's on the beam. So that also is going to point negatively. If this is my origin and I applied a force like that, the bar would spin around like this, which is clockwise. We call clockwise negative. Lastly, I do have a force from the hinge. So let's say there even is a torque from that hinge. We'll just say that, and that is torque net. So all of this is equal to 0. Now I know in general an individual torque is equal to Fr sine of theta. So that tells me then that the torque from the tension force is going to give me, I'm going to replace this now with Ft RT sine of theta t and I'm going to subtract that from FGS RS sine theta S, and I'm going to subtract it from FGB RB sine of theta B. All these subscripts mean is that it's the force, the magnitude of the force, times the distance that it acts away from the axis, so the distance from the axis, times the angle at which those two vectors are make. So lastly, I've got plus the hinge force, the magnitude of the hinge force, RH sine of theta H. But notice, right here, what is R? What is the distance that the hinge force acts with respect to our origin, with respect to the axis? Well, the distance is 0. It is 0. And if it's 0, that means this whole thing goes away. That whole thing is 0. If that's 0, multiply it by anything, the whole thing is going to become 0. So I know that all of this equals 0. So now I'm going to plug in some numbers. Why not? Let's plug in some numbers. So I know that 0 equals Ft RT. What is the distance RT from the axis? Well, that's 6 meters. The tension force is being applied 6 meters from my axis. So that's going to be 6 meters. Sine of, what's the angle between them? They give us 30. I found out because this is a 90-degree angle, that's got to be 60. So that's going to give me sine of 60. Oops. Sine of 60 minus FGS. If you look at your problem, FGS is 500 newtons. RS, well, what's the distance from the axis? That's 4 meters. RS is the distance the force is applied from the axis. That is 4 meters, so that is going to be 4. And then sine of theta S. My R vector would point like this. The FGS points like this. That's at a 90-degree axis. Sine of 90 is 1. Minus FGB. FGB, if you check again on your problem, it tells you that the weight of the bar is 100 newtons. So that's 100. RB, it's being applied at the beam's center of mass. That is 3 meters away. So if that is 3 meters away, that's going to be 3 meters for my R. So the force is acting 3 meters away from the origin. Sine of, what is the angle here? The angle is again 90 degrees. So that's going to give me 1. And I know all this is equal to 0. I only have one unknown. I can solve for the tension force. So I get Ft equals 500 times 4. That's 2,000. I'm sorry. I'll take these and add these over here. So if I take those and add those over here, this is going to be 2,000. And I'm going to add 300. So over here, that's going to be 2,000 plus 300 is 2,300 equals Ft6 sine of 60. Lastly, I'm going to divide by 6 sine of 60. And I'm going to get my tension force. And so my tension force will be, it'll give me 443 newtons. 443 newtons. So I just solved for this. I mean, all this part after this is just math. So next they ask for us, okay, great. Find for me now, they call it Rx and Ry. I'm going to call it Hy and Hx. That's part C. I'm sorry, this isn't part A, this is part B. So part C, I'm going to use, because I find it simpler, I'm going to use the idea that F net along X has to equal 0, and that F net along Y equals 0. F net along X. So, the only components I have acting along X are this tension force and the hinge force. There's FHX, and then there's going to be the tension force along X. That's that component there. I would also have a component here of Ft along Y. So this is Ftx, this is Fty. So that tells me that I'm going to have Hx, which is pointing positively. Fhx points positively that way, and then Ftx, which points negatively the other way. And all that equals 0. So to find Fhx, or Rx as they're saying, I'm just going to add Ftx, add Ftx. So I got Fhx equals Ftx. Now, what is Ftx? The second I find Ftx, I've got Fhx. Ftx, if this is 60 degrees, here is the adjacent part, the Ftx is the adjacent part of the triangle. Fty would be the opposite part of the triangle. So I know that cosine of 60 degrees is going to be the adjacent Ftx over the hypotenuse, which is Ft. And I know that Ft is 443 newtons. So if that's 443 newtons, I multiply Ft over here. So I get that Ftx equals 443 cosine of 60. If I do all this, I should get that Ftx equals 222 newtons. 222 newtons. So that's that part. Last part would be all along Y. So what is F net along Y? What if I add up these along Y? I have a Y component here from the hinge. I've got a Y component here from the tension force. And I also have the force of gravity from the beam and the force of gravity from the sine. So that's Fhy plus Fty minus Fgb minus Fgs. So that's Fhy plus Fty minus Fgb minus Fgs equals 0. So I'm solving for this. I want to find this. So I was going to take all this and put it on the other side. So that's going to give me Fhy equals Fgb plus Fgs minus Fty. Fgb is 100 newtons. Fgs is 500 newtons minus Fty. So Fhy equals 600 minus Fty. So how can I find Fty? The same way I found Ftx here. I know the hypotenuse, the magnitude of the tension force is 443. This is 443. So I got my 60 degrees here, and Fty is opposite of my triangle. And I know that sine of 60 is going to give me Fty, the opposite, over the hypotenuse, or the magnitude, Ft. Sine of 60 gives me opposite over the hypotenuse. Fty over Ft. Multiply by Ft, that cancels out. Multiply by Ft, and that's going to give me Fty equals Ft sine of 60. So I'm going to take this, plug this into here. That's going to give me Fhy equals 600 minus, and then I'm going to replace it with this. Ft is 443. So that's going to be 443 sine of 60. I do this, and I'll find Fhy, and I'll be done. So you should find that Fhy equals 216 newtons. So I hope that helped. Again, please email me, or if you have any questions. Yes, please do the review.